Hello everyone, this is Sarita from Sri Venkateshwara College of Engineering. I am here to explain about the dynamic routing algorithm, that is the Dijkstra's algorithm from the computer network subject. Let's see the brief concepts of Dijkstra's algorithm. First is algorithm basics. Dijkstra's algorithm finds the shortest path between the nodes. Its use cases. Tesla's algorithm is used in transportation and communication network. So how the communication in network it is used? We will see it in detail now. Next is implementation. Tesla's algorithm uses the priority queue to optimize efficiency. Next is advantages of using Dijikra's algorithm. Dijikra's algorithm guarantees the shortest path for only the positive edges. It is not useful for using with negative edges. So let's see the Dijkstra's algorithm for networks. It is the finding the shortest path between the source node to the destination node. So here is the graph which where each node is represented as the here we can see the 0, 1, 2, 3, 4 up to 8 is there. So all these 8 nodes are represented as the routers. So we'll find the shortest path between the source nodes from 0 to all other nodes. So let's begin. Step 1. Initially set this SPT set, that is the shortest path tree set, as empty. Then assign all the vertices with the distances. Uh, Starting with the source node as a 0 and all other sources as infinity. Next, add the source node to the SPT set. 0 is added here. Next, add the adjacent nodes to this set with the distance values. Step In step 2, include the adjacent vertex of source node having the minimum distance value. That is, 1 is having the minimum value distance value, that is 4, whereas 7 has the 8 value. So 1 is added to the SPT set. Then add the adjacent node values of 1 to the SPT set. Here 7 is also the adjacent value for 1, as you can see here. Source node 1 has the 7 as the adjacent node, but adjacent node 7 is already added to the SPT set, so we can't take it as once again. Next is moving on in the same process. Next we can see that node 2 has the distance value as 12 and node 7 has the distance value as 8. So 7 is included in the SPT set. Then the adjacent values of node 7 are added with their distance values. Here we can see as 8 has the 15 as the distance value and node 6 has the distance value as 9. How it is calculated means from 0 to 7 the distance is 8, then from 7 to 6, that is 8 plus 1 9. So from 0 to 6 the distance value is 9. Similarly from 0 to 7, then 7 to 8, this 8 plus 7 it will be 15. In this way the distance is calculated. Now here we can see the SPT set as 0, 1 and 7. Next is now from the set we can see that 6 has the minimum distance value. So 6 is included in the SPT set. Now the set becomes 0, 1, 7, 6. Now add the adjacent nodes of 6. That is adjacent nodes of 6 are 8, 5 and 7. So since 7 is already added, so we exclude it and we will add 8 and 5. Now next check whether which is having the minimum distance. As you can see 5 which is having the minimum distance value. So we will add it on into the SPT set. Next, in the next, so here you can see 5 is added to the SPT set. Next, add the adjacent vertex of 5, that is 3 and 4. On adding 3 and 4, the distance value from 5 to 3, that is 11 plus 14, that will be 25, and 11 plus 10, that will be 21. So we can see that already we are having the distance 12 or node 12, node 2. So we will choose node 2 now in the SPT and include it in the SPT set. Then add the adjacent nodes of 2, node 2, that is 8 and 3. Node 2 adjacent vertex are 8 and 3. Then if we add the distance values uh, from 12 plus 2, that is 14. Next to 12 plus 7, that will be 19, and 12 plus 4, that will be 16. So least value is 14. So next is 8 is added into the set. So as you can see here, node 8 is added. Then add the adjacent nodes of node 8. Since node 8 all the adjacent values are added, that is 7 and 2, and 6 is also added. So move on to the next minimum value. That is, we have calculated 12 plus 7 as 19, and 12 plus 4, sorry, 5 is already added. So 12 plus 7, that is 19. So next 3 is added to the node. Next, from 3, if we take 4, the distance value will be 19 plus 9, that will be 28. So if we choose from node 5, that is 11 plus 10, that will be 21. So finally, from node 5 to 4, that is node 4 is chosen. Finally, we obtain the shortest path tree. So we can see that from source node 0 to 1, the distance is minimum distance is 4. If we go from 0 to 7, it will be 8, and from 0 to 2, the minimum distance is 12. From 0 to 3, the minimum distance is 18, and from 0 to 6, the minimum distance is 9. From 0 to 5, minimum distance is 11, and from 0 to 4, minimum distance is 12. So this is how Dijkstra's algorithm is applied for finding the shortest path between the source node to the destination node, that is 1, 2, 3, uh, next remaining 7, 6, 5, 4, all other nodes. But if we take the distance from other nodes other than these what we have chosen, example for 0 to 2, if we take from 0 to 7, then to 8, then to 2, it's the longest path. So we will choose the minimum distance, that is 0 to 1, then 1 to 2. It is 4 plus 8, it is 12. So this is how the Dijkstra's algorithm works out. Comparing the Dijkstra's algorithm, we see that out of 100 users surveyed, that is out of 100 users surveyed, 93% found Dijistra's algorithm to be speedy enough for their routing needs, and 23% of users experienced errors. That is, uh, maximum 93% of have given the feedback that it is speedy enough for their routing needs. At last, here is the quote which is given by the Dijkstra himself. If you can solve this problem efficiently, you can solve many other problems efficiently as well. Means this Dijkstra's algorithm is the best way for choosing the router with minimum distance. This is all about the shortest path algorithm, that is Dijkstra's algorithm for finding the shortest path between the source router to the destination router for network traveling, network communication. Thank you.